Are you tired of your pond smelling? Algae and hypoxia getting you down? Surface runoff from your fields and a high sediment and nutrient load in your delicate ecosystem? Well, do we have the thing for you? Introducing the Vegetated Filter Strip 5000 Max Turbo, the best vegetated filter strip to match all of your sediment, nutrient, and other surface runoff containment needs. It's the strip of vegetation that filters surface runoff contamination.
Vegetative filter strips are widely used across several applications to reduce sediment and nutrient loads. So what exactly are vegetative filter strips? Really, it's in the name. There are rows of planted or existing vegetation that filter contaminants from surface runoff. Vegetative filter strips are used most often to reduce the loads of sediments and nutrients such as nitrogen and phosphorus, but they can also be used in specific contaminant applications such as for pesticides. Vegetative filter strips can be found in a variety of locations, such as in wetlands or other riparian zones, in agricultural settings, or in urban settings like golf courses. But how do filter strips do this? The primary job of the filter strip is to slow the velocity of surface runoff. Most chemical contaminants will be dissolved in the runoff or attached to suspended sediments. When the water velocity is reduced, suspended particles begin depositing, which encourages infiltration of the runoff and the uptake of nutrients by plants. So what is sheet flow? As surface runoff drains, there are 3 different stages of flow. Sheet flow is the first of these stages. This flow is a thin, continuous sheet of water flowing downslope. Here, the water is not concentrated into channels. Once the water does start to be concentrated, it forms small, removable channels called rills. If this continues, a full channel can develop. As surface runoff enters the vegetative filter strip, the velocity of the shallow uniform flow decreases when it encounters the dense vegetation of the strip. This decrease in velocity slows the water enough to drop below the deposition velocity of sediment, allowing suspended particles to drop out of the water. Larger grain sizes like sand will be deposited first, and then silt, and finally clay. Vegetative filter strips offer several different ways to reduce nutrient loads, including uptake by plants, use by microbes, deposition of sediments, and absorption or immobilization of nutrients into soil particles. Now that we are discussing nutrients, it is important to make a distinction between 2 different types of vegetative filter strips. The first is called an edge of field strip. This vegetative filter strip, found on the edges of a field or an upland area, exists in an aerobic environment with well-aerated soil and well-drained soil. The second is a riparian buffer. These are found bordering bodies of water, such as a pond or a river. Because of their proximity to water, some of the soil will be saturated. Riparian buffers have areas of both aerobic environments and anaerobic environments. Most of the removal and uptake of phosphorus is done by the soil or substrate in the vegetative filter strip. Clay particles are negatively charged. This means that the positive ions are attached to the soil colloids. Phosphate is attracted to the positive iron. Because of this, it is attached to the soil. It is associated with the clay, and the phosphorus will move with the sediment.
So, now would you like to implement an upland edge-of-field vegetated filter strip system? Great! But how would you design the most efficient system?
Well, there are a few things you need to remember. The wider the filter strip is, the better. This gives more opportunities for infiltration of surface runoff and the deposition of sediments. You also want to slow down the surface runoff as much as possible. This means you want to use the smallest slope as possible in your strip. And you want to have a very dense root system at the base of the vegetation to slow the water as it flows through. This also allows for more nutrient uptake. You need to make sure that the surface runoff is encountering the vegetative filter strip as a sheet flow. And if you're interested in nitrogen removal, you must have a wet zone.